An introduction to the computer network. Introduction to LAN. Various kinds of LAN. Let's proceed to the following topic. The topic is very important. We are here to introduce various kinds of LAN. In our environment, LAN is mainly composed of Ethernet because everyone will have contact with it. We all intuitively recognize that LAN is the Ethernet. It is similar to this Ethernet network. In fact, we should have an important concept. There are various kinds of LAN. It's not just Ethernet of Ethernet family. What about the LAN? In fact, LAN includes FDDI, token ring, and Ethernet, and others. Because the speed of Ethernet is fast and the price of Ethernet is very cheap, all other kinds of LAN are replaced by Ethernet. Here, what we want to emphasize is that Ethernet is not the whole of LAN. The LAN includes kinds of networks like FDDI, token ring, ring network, etc. The figure on the right side can make it clear. FDDI, a ring network, can connect to the router. Token ring, also a ring network, can connect to a router. Ethernet, a bus network, can connect to the router too. Therefore, it is a very important concept. The router can be installed with different kinds of network cards, including Ethernet and others. There is a red paragraph on the slide. It can help everybody learn why there are these different LANs. Advantages of Ethernet. Although the speed is very high, the disadvantage of Ethernet is that the transmission time is non-deterministic. So its utilization rate is only about 30% to 40%. Fast Ethernet's theoretical bandwidth is 100 megabytes. In fact, its utilization is only 30 to 40 megabytes. There may be some restrictions. If the speed is faster than 40 megabytes, what about the token ring and FDDI? They are phased out. However, they still work in some environments. Its advantage is that its transmission time is deterministic. For example, for every computer, every device, I can predict the time of transmission. And what are the benefits? Here is an example. Nowadays, machines are used in industries, including the CNC or tool machines. In fact, the network equipment inside is not necessarily Ethernet. They use a network called ArcNet. ArcNet is an aged network. Its speed is very slow. Less than 10 megabytes of Ethernet. At present, even Ethernet has reached 100 megabytes. 1 giga is 1 gigabyte per second. However, ArcNet is still used on the tool machine. Its speed is only about 3 megabytes. Why? CNC machines or other machines in factories, the network they need is not fast. They need the precise processing time. Ethernet can't meet this requirement. Therefore, they still use the ArcNet. Because of it, ArcNet sends packets by turns. Therefore, we learn an important concept. Ethernet is not the whole LAN. There are many kinds of LAN. Okay then, let's proceed with the next topic. What about the Ethernet family? We can have a look. The earliest speed of the Ethernet family is 10 M. What about the speed of fast Ethernet? At present, we are probably using it. Fast Ethernet speed is 100 megabytes per second. And then there's Giga Ethernet. Have a look at these two ports. What about these two ports? They are for uploading. The speed of these network ports, packets, will go through these two ports, upload again. So what about the velocity of these two ports? They will be faster and faster. This is Giga's BPS. There is a very important concept that we should understand. What does BPS mean? You all probably know bit is a bit. What about byte? That's 8 bits. That is, 1 byte is equal to 8 bits. What is the meaning of BPS? It's bits per second. Notice that the unit is bits per second. In the slide, the emphasis is very clear. It is not bytes per second. Don't be confused. Introduction to LAN cable. LAN cable. Okay, let's take a look. Cables for LAN. Included in the drawing, optical fiber is displayed on the figure. For optical fiber, and this twisted pair, we currently use twisted pair. That also includes wireless networks. There are some types of LAN cables. Then we need to understand. To plan a network, first you need to know which kind of cable you need. There are many specifications in cables, but we should not be too nervous. We only need to know each cable's transmission distance. Available transmission distance. That's fine. That is, we need to understand the length and bandwidth of the cable. This cable is a twisted pair. It's called a twisted pair. In fact, there are 2 types of twisted pairs, straight through and crossover. This twisted pair has straight through and crossover. That's different. The difference between the straight through and crossover are different in color code sequence. The color on the top. On the next slide, we will mark it clearly. What about the optical fiber? Optical fiber. Please watch the slideshow. Optical fiber. Very, very fine. How thin is it? Optical fiber is thinner than a hair. And what about optical fiber and its kind? It is divided into single mode and multi-mode. At present, we probably all use single mode transmission. That's about optical fiber, because in the future, we may plan optical fiber networks. Let's learn about optical fiber. In a network project, optical fiber might be a little dangerous to careless engineers. That fiber is dangerous. We can't directly see the optical fiber connector with the naked eye. That is to say, you see the light on the projection is very beautiful. But you can't look directly with your eyes because the light it injects inside is laser light. You can't actually see the laser light. Although the laser light cannot be seen, it'll burn your eyes. Once I learned from a network project that when installing a large-size router, a laser beam was injected from the remote router. When we plugged that connector, on connecting that device, the equipment was burned out. How far is the distance? About 2.3 kilometers. So far away. The careless network engineer did not adjust the strength of the laser light, so the optical fiber burned the equipment. When we encounter optical fiber in the future, it is important that you do not look at the optical fiber directly with your eyes. Many kinds of instruments and tools can help. Let's continue to introduce optical fiber. Single-mode optical fiber transmits laser light. Therefore, the distance of its laser light can reach far distances, can be up to 70 kilometers. Multi-mode transmission is LED light. The distance of LED light is relatively short. It's much shorter. There is an important concept about optical fiber. At present, one optical fiber is what it transmits, its bandwidth. In fact, there is no limit on the bandwidth. Therefore, we can replace electrical cables with optical fiber. What it can transmit. The bandwidth can be very, very large. The bandwidth is bits per second. Transmission distance of optical fiber will be very far. The bandwidth of optical fiber can be very large. And we have an important idea. Optical fiber, its transmission bandwidth is very enormous. What kind of use? What kind of network? For example, Ethernet. Ethernet protocol on optical fiber. The bandwidth is 10 megabytes per second. The 100 base FX on our slide. Look at the Ethernet protocol, 100 base FX. Its bandwidth, in this case, is 100 megabytes per second. It depends on which one you use. For example, FDDI. We use optical fiber. The bandwidth of it is 100 megabytes per second. That is to say, although you are on the superhighway, you can drive very fast, but you must obey the traffic rules. Characteristics of optical fiber. It's like a superhighway with no speed limit. But what kind of network architecture do you use? What kind of network card? The speed depends on the network card. This should be a very simple concept. End of the course. Thank you for watching.